It's Horner, and these are the directions on how to do the AP Physics 1 Center of Mass Learning Activity number 1. So you've already kind of watched some videos on what center of mass is and the equation for center of mass. So remember that if I want to find the position of the center of mass of a series of objects, all I have to do is take the mass of the first object times the position of that object plus the mass of the second object times the position of that second object and divide it by the total mass. So if you had more than 2 particles, you could do that with all 3 if you wanted to. So that's kind of what it should look like. We have 2 objects here, and they are located on the x-axis. One of them is located at 3 meters. So we've got 0. Let's just do 1, 2, 3. So we've got one object right here. And then we've got another one at 4 meters, which is right here. This one is a 2 kilogram mass, and this one is a 7 kilogram mass. And they want to know what is the position of the center of mass of the 2 objects. So to do that, all we're going to do here is we want to know the center of mass of the 2 objects. So we've got our equation right here. And we can say that position of the center mass is equal to our first object, which has a mass of 2 kilograms times 3 plus, and then we have our second object, which is 7 kilograms times its position, which is 4. So remember, this is 0, 1, 2, 3, 4. And now we need to divide that by the total mass, which would be 2 plus 7, which is 9. When you do that, you should end up with 3.8 meters. Now they're going to add another mass. They want to know where should you have it, so that will move the center of mass to the origin. So we've got to figure out where it's going to be. So it should be somewhere over on this side. So notice that it should be negative. We just don't know where it is, but we do know that that mass is 5 kilograms. So if we set up our equation x center of mass, that should be equal to the first mass times its position plus the second mass times its position plus the third mass times its position, all divided by the sum of all those masses, m1 plus m2 plus m3. We know that we want the center of mass to be at the origin. So we want that to be at 0. So this guy right here is going to be 0. You'll have to fill everything else in, and then you want to solve for this third x and see what it is. For the next one, they have a box, and they want you to find the center of mass in the x direction and in the y direction. So when you do the first one, we're going to do x center of mass. And we're going to go ahead and take a look at everything in the x direction. So when we do the x direction, we have to think about, well, x center of mass, and that should be equal to the mass of the first times its position from the center, plus the second one, plus the third one, plus the fourth one. So you'll notice that this third one is above it, okay? So it doesn't change, so we don't have to worry about number 3. However, we are going to worry about number 4 and number 2, and we're going to start right here. So the center of mass for this object in the x direction only is going to be equal to the mass of the first object times its position from, or distance from, that first object, plus the mass of the second times the second, plus mass of the third times the third, plus mass of the fourth times the fourth, and then we're going to divide that by the total, which is going to be m1 plus m2 plus m3 plus m4. All right, so here we go. xcm is equal to, so our first mass is 1, but it's at 0. Our mass number 2 is 4 kilograms, so this is plus 4, and it's times 2 meters, plus the mass of the third, which is 2, but it is from, in the x direction only, It's only in the y, so it's at the same position in the x, so that one's 0, plus the mass of 4, which is 3, times its position. And notice that it is along this line. So we want to know what is this line right here. So we've got to figure out about how far is that left to right. So we don't worry about the line because that's at an angle. Instead, we're just worried about left to right. And if you go left to right, you'll notice that it's only about 2. Now we're going to divide that by the total, which is 4 and 3 is 7, 8, 9 plus 1 is 10. So that's going to be 10. And your position for the x center mass is going to be 1.4 meters. I'm going to leave it up to you to do the y. Notice that this one does have a y component. This one also has a y component, but this one does not have a y component. It's at the same level. So watch out for that one. Next thing they want you to do is find the location of the center of the mass of the Earth-Moon system. The masses are given here, and the distance between their centers is this. So that one should be easy to do just using the equation. You have 2 kids sitting at the end of a teeter-totter. They do tell you that the teeter-totter is 3 meters long. So this is a total of 3 meters. They want you, and it has a mass of 10 kilograms. So that's right at the center is going to be where that 10 kilograms is kind of thought of. And then we have a kid on one end, which is, this one is, we'll call this 50 kilograms. And then on the other side, this is 35 kilograms. So we have 3 masses, 1, 2, 3. We know the entire distance from left to right here is this 3 meters, okay? So this whole thing is 3 meters. And you've got to find the location of the center of mass of the 3 objects. So I would start at this point right here and make this 0 meters. Right here is going to be 1.5 meters, and then the 35 kilogram, this one is at the full 3 meters. And now you can go through and find x center of mass. That would be where you would need to put a pivot so that they could all balance. Don't forget about the board. The board is important, and the center of the board is at 1.5. So when you do that one, make sure you put the center of the board at 1.5. Next one is this little guy here. It is very, very similar to the one that we did here, except for it is an object. So you'll notice that this object is shaped like an L, kind of turned on the side. They want you to find the x and y coordinates of the center of mass of the piece. For the very last one, this is number 6, they want you to find the total center of mass for a system consisting of these 3 masses. Then they're going to add an object, and you want the center mass to be at 5. And then they want to know how much mass should be added, or how much mass should be located at 10 meters, or 10 whatever, because it didn't give any units here, to the original system. So be careful, so that the new mass at x10 has a center mass at x equals 6. And that is the first one. For the second worksheet, this one is center of mass worksheet 2. So in the grid, every box represents a meter. So from here to here is a meter, from here to here is a meter, up and down is a meter. And each of these 2 objects is moving at 3 meters per second. Draw a dot where you think the approximate center of mass is. So we are going to, on this one, draw the center of mass about right there. That's where we think the center of mass is. And then this one is right here. So we have an equal amount of mass on both sides. This one, we've got a pretty equal amount all the way through. I guess the other thing that you could do on this one is, if you want to, you could move that slightly down, but in the end it's not going to matter. So both of these objects are moving to the right at 3 meters per second. So we're going to go 1, 2, 3, and then it goes 1, 2, 3, and then it goes 1, 2, 3. And they wanted us to do this for each of the next 4 seconds. So this is 0, 1, 2, 3, and then 1, 2, 3, and then there's 4 seconds. This one is going to have the same thing. They want us now to find the velocity of the center of mass. We're just going to see that it's moving over to the right, at 3 meters per second. Because, why? The center of mass between the two objects is going to be located right here. And we notice that as it moves, it's moving at the same rate. So this one is actually 3 meters per second. Now we're going to think of the two objects as one system. So instead of individual objects, we're going to look at them as one system. So the two objects here are a system. This object has 3 times the mass, so this one is 3m, and we're going to call this one m. That makes it really easy. And each object remains at rest. Show the location of the center of mass for the system at each second for the next 4 seconds. Well, we just need to find the center of mass. So the center of mass here we know is xcm, and that's equal to the mass of the first one, which is m, times its position, which we know is going to be 0, because that's where we're starting, plus the mass of the second one, which is 3m, times its position. So its position here, if we count, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it is 16 from the center of the other object. And then we're going to divide that by the total mass, which is 4. So what I'm going to do here is just take 16 times 3. And 16 times 3 is 48. And then I'm going to divide that by 4, and I end up with 12. So now I've got to go over 12, so 16, 15, 14, 13, 12. This, and we're going to label it as xcm. That is the position of the center of mass of the two objects. So if I had the two objects connected, maybe with a meter stick, I would have to put my finger here in order for the two objects to balance on that meter stick. They want to know what's the velocity of the center of mass. This is going to be 0, so that makes it a little bit easier. We can do the same thing now with the two objects here, but we're going to think of them as one system. Okay, and this one is going to be moving to the right at 4 meters per second. So here we go. This one starts here, and it's going to go 1, 2, 3, 4 meters per second. So that's where it would be. This one's going to do the same thing, 1, 2, 3, 4. So they both have the same speed, so that makes it a little bit easier. They want us to go through and show the location of the mass of the system, center of mass of the system, at each second for 4 seconds. So first we have to find out what is the center of mass of this system. So we're going to make this 0, and we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. And we want to find out what is xcm first. So xcm is equal to the mass of the first one, which is m. This one's 2m and this one's m. They told us that up here. And so this is m times 0 plus, and then we've got 2m times 9. And we're going to divide that by 3. Well, why did we do it by 3? Because it's 2m plus m, so that's going to give us 3. So now we've got 9 times 2 is 18 divided by 3, and that would be equal to 6. So our center of mass is at 6, so 9, 8, 7, 6. So this is our center of mass. Now what we've got to do is go through, and we want to figure out if the object, each object is moving to the right at 4. So they want us to find the location of the center of mass system at each second for the next 4 seconds. So now it's going to move 1, 2, 3, 4. So this is, bigger dot is the center of mass again if it moves. And then 1, 2, 3, 4. So as the whole thing moves, this is going to move over also at the same rate. So this is also 4 meters per second. How could we find that using the equation? So let's do this. The velocity of the center of mass is equal to the first mass times its speed, which is 4, plus the second mass, which is 2m, times its speed, which is 4. And we're going to divide that by the total of the mass. So 2 mass plus 1 mass is going to be 3. So now what we need to do is we're going to take 4 times 2 is 8. And 8 plus 4 is 12, so this is going to be equal to 12 divided by 3, and that magically is 4. So at this point I'm going to stop and I'm going to have you go through and finish. So here we've got two objects again. This thing is the system. It talks about object B is at rest this time, and object A is moving to the right at 4. So use the same thing that we've done here to figure out kind of what's going on. On the next page, we've got the same, basically the same thing on number 5 and number 6 and number 7. So just use your equation and you should be able to do this. The velocity of the center of mass in